Hi students, now we discuss about the continuation topic of osmotic pressure and this is reverse osmosis. Reverse reverse osmosis. Okay students, osmosis means osmosis os, reverse osmosis. The first of all, osmosis means the process of flow of the solvent through semi-permeable membrane, but we have taken osmosis, reverse osmosis. Suppose this is one type of container, this is another container, it is the pressure, it is also pressure. This is one type of solution and solvent. Okay, osmotic pressure means the process that just prevents all the flow of solvent at the same particular pressure. Suppose this is semi-permeable membrane, the flow of water is passes through semi-permeable membrane to A, B. To reach solution, some quantity of pressure is applied on it, the flow of water is reduced. This pressure is known as osmotic pressure. But reverse osmosis means how much quantity of pressure is applied on the solution is reduced. This reduced flow of solvent, this pressure is more applied more than pressure. The pressure is applied greater than osmotic pressure. The pressure is applied greater than osmotic pressure. The flow of solution like NaCl molecules is passes through in a solution to solvent, solvent. You have applied pressure is greater than osmotic pressure. The solution particles like NaCl particles is passes through in a semi-permeable membrane to solvent. This is reverse osmosis, RO. Reverse osmosis. Generally, the solvent particles passes through in a SPM, semi-permeable membrane to solution at the particular pressure. To this pressure is reduced to solvent particle flow of solvent particles, that is osmotic pressure. But reverse osmosis means you have applied some quantity of pressure, this pressure is greater than osmotic pressure. You have applied pressure is greater than osmotic pressure. This pressure due to the solvent particles like NaCl particles is the solvent particles is flows through SPM to solvent. This process is known as reverse osmosis. Suppose example, this reverse osmosis is used to RO plants like seawater is purification, and seawater is purified to pure water like RO plants, and it means purification of water, purification of water. This is reverse osmosis. Next, this reverse osmosis, the next topic is isotonic solutions. Isotonic solution. Isotonic solution means two solutions having same osmotic pressure. same osmotic pressure. Two solution having same osmotic pressure at given temperature. At given temperature is known as isotonic solution. Isotonic solution means you have taken two solutions. These two solutions having same osmotic pressure. This is known as isotonic solution. Suppose example, our blood. Our blood should be contains of 0.9% of NaCl. 0.9% of NaCl, and the 0.9% of pure NaCl is present in purified blood. This is isotonic solution. NaCl is a same equal quantity of osmotic pressure, and our blood contains of equal quantity of osmotic pressure. Okay, these isotonic solutions should be contains two types. The first one is hypotonic, and second one is hypertonic. Hypotonic solution and the second one hypertonic solution. The hypotonic solution means our blood contains of hypotonic. Hypotonic means our blood contains of plasma and NaCl. Plasma and NaCl and blood particles. Blood particles should be hypotonic. Hypotonic solution means hemolysis, like hemolysis means our blood should be contains of hemoglobin, that is RBC, WBC. Okay, hemolysis means erythropoiesis. This type of particles are present in our blood, that is hypotonic. This is also same osmotic pressure, hypotonic, and this is also hypertonic means same osmotic pressure. Hypertonic means plasmolysis. Our blood contains of water like that, plasma. This is equal quantity of osmotic pressure. Isotonic solution means two solution having same osmotic pressure at given temperature. Example, our blood and the content should be contains of 0.9% of NaCl. The isotonic solution is divided into two categories, like hypotonic and hypertonic. Hypotonic is homolysis of solutions, and hypertonic is plasmolysis of solutions. Thank you, students.